Okay, so today we'll try to understand how to draw the Mohr circle. Suppose we are having a component which is subjected to the biaxial stress system. So these are the stresses in x and y direction, and these are the tensile stresses. So suppose in the x direction we are having sigma x is equal to 100 MPa tensile stress, and in y direction also we are having sigma y is equal to 30 MPa, and that is also tensile. Then using the Mohr circle method, we can find out the various stresses on any plane which is inclined inside the material. Okay. Suppose that plane is inclined at an angle of theta. Then let us see how to find out these particular principal stresses. Now, as we have already seen that sigma x is equal to 100 MPa and sigma y is equal to 30 MPa. So we can take some suitable scale, that is 1 centimeter is equal to 10 MPa, and we can draw two axes. Let us try to understand what is the significance of this particular axis. On x-axis we are having the normal stress, and on y-axis we are having the tangential and shear stress. As you have already seen in the previous figure, our sigma x value is 100 MPa. So if we take 1 centimeter is equal to 10 MPa as a scale, then 100 divided by 10. So from O at a distance of 10 centimeter, you can locate point A representing sigma x. Similarly, sigma y is equal to 30 MPa, and that is also positive. Tensile stresses, they are considered as positive. So on the positive x-axis, again we'll take some 3 centimeter length, and that is the representation of sigma y. So this is the positive normal stress and this is the negative normal stress, or you can say that this is the tensile stress axis and this is the compressive stress axis. Similarly, this is the positive shear stress and this is the negative shear stress. Now, as in our case, both the stresses, they are tensile. Both these values, that is sigma x and sigma y, by scale, they are lying on the right hand side of this particular point, that is O. So find out the midpoint of this particular AB. So suppose that midpoint is C. With C as a center and CA or CB as a radius, you can draw a circle, and this circle is known as the Mohr circle. Now suppose we want to find out the stresses at any plane which is inclined within the material, correct? And suppose that plane is making an angle of theta. Then here from CA you have to mark the point in such a way that this included angle will be 2 theta. Drop the projection on x-axis. Join this with this particular O also. Then this is known as the normal stress. So from O as a reference, if you measure this length, then this is known as sigma d. That is the normal stress at point D. Similarly, this vertical length, right, will be nothing but the shear stress at point D. So we can say that at point D we are having the normal stress as sigma d, that is represented by this particular length. So measure this length, multiply it by scale. Similarly, measure this particular length and multiply it by scale. You will get the value of tau d, that is the shear stress at point D. This particular segment, it represents the resultant stress which is acting at this particular point D. So we can say that at point D we are having sigma d, that is the normal stress represented by this line segment. Similarly, shear stress represented by this particular line segment, and this is the resultant stress that is acting at this particular point, that is D. Now this angle is 2 theta, that is the most important